Hello, dear students. I am L.P.BHAIYA. This is your unit number 5, Oscillators, part 2. We have already studied about the oscillator, basics of the oscillator, and the RC oscillators we have studied. RC oscillators. Now, this is part 2. We will study about the LC oscillators. Let us see what we have studied till now. This is oscillator, introduction to oscillator. We have already gone about the linear oscillators, Wein bridge oscillator, RC phase shift oscillator. Now we will go for the LC oscillators. This is already we have seen. This is about the LC oscillator. You can observe here in LC oscillators we will use this as the amplifier, and this is the circuit. This is called as a frequency selection network Z1, Z2 and Z3, which provides a phase shift of 180 degree, and the amplifier will provide the phase shift of 180 degree, so that total phase shift around this loop is 360 degree as per the criteria of the oscillator. Here in LC oscillators, two well-known oscillators in our syllabus are the Colpitz's oscillator and the Hartley oscillator. We will see about these oscillators. This is the general diagram of the oscillator, where we have this tuned circuit, or you can say this is the frequency selective circuit, and this is the amplifier. Then we can calculate the impedance here by as a ZP. This ZP is shown here, and this is the feedback voltage VF. So this VF we must need, and we need the ZP is the equivalent impedance of the tuned circuit. For the equivalent circuit, and from this equivalent circuit we can calculate the output and loop gain. This is shown here as the A beta is the loop gain for this equivalent circuit for this oscillator, and then we can find the criteria of the oscillator. The loop gain around the oscillation A beta should be equal to 1. It is shown here. This is A beta is equal to 1. These are the two circuit diagrams of Hartley oscillator and Colpitz's oscillator using transistor. You can see here, very simple to remember. Here we will use the two inductors L1 and L2 is in series along with the parallel of this capacitor, is called as a Hartley oscillator. And in Colpitz's oscillator we will use this C1 and C2 in series along with the parallel inductor. Colpitz stand here C means C1 and C2. Hartley means here L stands for L1 and L2. So you can easily remember Hartley means two inductors and Colpitz means two capacitors. So two capacitor in series along with the parallel inductor, and these two inductors are in series along with the parallel capacitor. Here in Hartley oscillator, the frequency of oscillations is given by omega 0 is equal to 1 upon square root L1 plus L2 into C. While in case of the Colpitz's oscillator, this omega 0 is equal to 1 upon square root L into Ct, where Ct is the equivalent value of the capacitor C1 into C2 upon C1 plus C2. While transconductance Gm is given by L1 by L2 into 1 by R. Similarly, here Gm is equal to C2 by C1 into R. So these are the two well-known oscillators. LC oscillators use Hartley oscillator and Colpitz's oscillator. LC oscillators means inductor and capacitors are used. This is the equivalent diagram. This is the Colpitz's oscillator, and we will use the small signal transistor here, small signal transistor model, by which small signal transistor model of which equivalent circuit is used, and using this equivalent circuit we can calculate the various parameters like frequency, like a small signal frequency analysis and other things. Linear small signal model of transistor is used. The transistor capacitance are neglected. And input impedance of the transistor is large enough. These are the assumptions which we made for analyzing the Colpitts and LC oscillators. This is the equivalent diagram and the calculation of the particular oscillator circuit. This is the frequency, and already we have seen just below the circuit diagram, which is determined here, omega 0 and this CT. This is the frequency of the oscillation. Omega 0 means here 2 pi f. So you can calculate f. F0 is equal to 1 upon 2 pi square root L into CT. And the value of the equivalent capacitance is CT is equal to C1 into C2 upon C1 plus C2. Then the important is the frequency stability. The frequency stability of an oscillator is defined as 1 upon this omega 0 into d omega by dt at omega is equal to omega 0 pulse per minute per degree centigrade. Use high stability, and to get this stability properly, to get a high stability, we must use the high stability capacitors. Example, silver mica capacitors, polystyrene capacitor or Teflon capacitors, and low temperature coefficient inductors must be used for the high stable oscillators. Then amplitude stability. In order to start the oscillations, the loop gain is usually slightly greater than unity. A beta is called as the loop gain, and this should be slightly greater than unity. LC oscillators in general do not require amplitude stabilization circuits because of the selectivity of the LC circuits. Since we do not need to have the amplitude stability, because this stability can be obtained using the LC circuit. Therefore, we don't need it. And in RC oscillators, some nonlinear devices, for example, negative temperature coefficient and positive temperature coefficient resistors called as a NTC or PTC resistors, FET or Zener diode, can be used to stabilize the amplitude. In RC oscillators, we need sometimes to stabilize the amplitude. So this is about the oscillators. Dear friends, you can go through the various books, standard books for referring this oscillator, and if you have any problem, kindly you can call me so that we can solve your problems on the particular oscillators. All the best. Prepare this topic oscillator properly. Thank you very much.